Hello everyone. In this video we will be solving this exercise about integration by substitution. Here we are given this substitution that u is equal to sine x and we need to find this integral. So as we know from the integration by substitution, we need to replace all of these functions in terms of x to become in terms of u instead. So here we will replace this sine x by u, but then we have to find a way to replace dx and cosine x also in terms of u. So first, whenever we are given an integration by substitution, first we need to differentiate this substitution itself. So now when we differentiate, the u will become du. When we differentiate sine x, it will be cosine x and times dx. So this is the derivative of the substitution. But as you see here, we have only cosine x, but in the question we have cosine cubed x. So to use this here in this integral, I will separate the cosine cubed x into cosine squared x multiplied by another cosine, like this. So first, the integral will become, instead of cosine cubed, I will write cosine squared x multiplied by cosine x. Now all of that divided by square root of sine x as it is, and then times dx. As you see here, du is equal to cosine x multiplied by dx, which is the same as this expression. So this will be replaced by du, and this by u. So what about cosine squared x? We have to find a way to replace it in terms of u, but here we don't have cosine in the u. So that's why I will use the Pythagorean identity sine squared x plus cosine squared x equals 1, as we know. So if we solve for cosine squared x, it will be 1 minus sine squared x. And now I will replace this cosine squared here for this. So the integral will become, instead of cosine squared, I will write 1 minus sine squared x. Then here we have times another cosine. All of that divided by sine x, or the square root of sine x times dx. So now as you see, this will be replaced by du, and this by the square root of u. So we will have now 1 minus. Here, instead of sine squared, we will write u squared. So now we have minus u squared, and divided by, here we have the square root of sine, which is the square root of u. And as we know, square root of u can be just written quickly and more conveniently for integral as u power of half. Then here we have cosine multiplied by dx, which is, as we said, du. So here, to integrate this, I will separate the fraction first. So we will have integral of, first I will write 1 over u power of half minus u squared over this as well. So 1 over u power of half minus u squared over also u power of half times du, which can be written now like this. Here we can send u power of half up and make it negative half instead. So u power of negative half minus, here in this fraction, when we divide these u's, then we will subtract the powers according to the power laws. So we will have now u power of 2 minus 1 over 2, which will be 3 over 2. And here we have du. So now we will integrate as we learned in the video that's about basic integrals that you can see the top right of the screen. So when we integrate here, we will increase this power by 1. Now, here, u, instead of this power here, I will put negative half plus 1, which is positive half. And then we divide also by the same new power half. Minus now, here, u power of, So here we have a power of 3 over 2. When we add 1 to this, it will be 5 over 2. So here we have 5 over 2, and we divide by the same new power. Then we have plus c, as we know. As we learned in that video as well, we can take these fractions in the denominator and write them up, but we have to write the reciprocal of these. So 1 over 2 can go up and become 2 over 1, which is 2 instead. Then we have u power of half, which is the square root of u, minus also the 5 over 2 can be written up as 2 over 5, but then for the u here, as we know, since we have a fractional power, the 5 will be written inside and the 2 outside like this. So here we have 5 and here we have 2, but generally we don't write 2 for square roots, it's automatically 2 like this. So now at the end of the integration, we shouldn't forget that we have to replace u back by what it was before, which is sine x. So we will have now 2 square root of u, which is square root of sine x, minus 2 over 5 square root of, here we have u power of 5, which is sine x and all power of 5. The sine is power of 5 plus c. So this is the final answer or the integral to this question.